Hi guys, so we're back with another tutorial on Unity, and today we're gonna start working on the animation series that I want to develop. So first we can add a new project. We are gonna use a universal render pipeline, and I'm gonna put it here teaching. Oh no, here teaching and here. Um, So, for instance, we're gonna put it here, and then we're gonna call it animation. For instance, animation project. I think that's alright. Good. So we're gonna be using universal render pipeline because I think that going forward that's the future, and I think although we could use the built-in render pipeline here, I think it's worth just going here. It's most of the things that we're gonna do we don't care, and if you get used to that, I think it's gonna be good for you. So now we create a project. It will come with a default scene that we're gonna delete. We're gonna delete almost everything there, so we don't want anything, except maybe for the URP settings, because we may be using those. And yeah, well, that's why it's creating it. It's I didn't I it's I mean I cannot show it to you, but it's the progress bar is happening in the other screen. By the way, we're gonna be using a connector from different channel. The channel is called Mix and Jam. It's a very good channel. I recommend you take a look at it. Really recommend you take a look at the channel because they got really interesting stuff. And we get in a character called Jamo, which is they made available for free. I asked them if it'd be okay to use it, and they said that's all right. So yeah, we're gonna be using that one, and we'll use animations from a service that um, what was the name? I can't recall the name exactly. It's the same one they use. Mixamo, that's right, Mixamo. So we'll get animations from Mixamo. It's a I really recommend you take a look at it. They've got great animations, and many of them for free. Some of this you have to pay them for them, but they got really high quality animations which are really good. So for starters, we'll look for an idle animation. And we will see later what we do, because probably maybe we'll use a different one later, because if we want to have the character handle a weapon, sword or whatever, we are gonna need to probably have an idle with a weapon, which I'm not sure we have right now. So yeah, we got the project. As I said, we don't care about the scripts, the scenes, the presets, the materials. How do you compress the memory of the stream. I'm not sure about these. I'm not gonna leave these. Last time I created a project where what we did, I didn't have them, or at least I didn't take a look at them. And we are. This is Skybox material. That's yeah, that's alright, but we're not gonna. So we're gonna get rid of that and these and these. The tutorial info too. And the README file. Yep. So we've got a very small subset of things, and we create a new folder called scenes. Create a new scene. I don't know. There, now it. Just call it main. Create a new folder. We're gonna call art, where we're gonna be having our materials, but also our models, stuff like that. Another folder called URP for universal. That stands for Universal Render Pipeline, and we made the presets and the settings. And another folder called code, which is the one we're gonna put our scripts. Yep, and don't say that one. Okay, so here we are. Yeah, in the Lightning, we're gonna change the default skybox for this one. I like this one better. Yeah. Okay, and here we go. Yeah. So, first thing we're gonna do is we are gonna add a 3D object, a plane or a quad. Let's create a plane, yes, because it's easy. Yeah. We're gonna make it big, so it's a 10 by 10, I think, by default. We're gonna make it like, I don't know, like 100 times 100. Yeah. We are gonna be, by the way, we're gonna be making it static. Generate lighting, yes, to make sure we got this. We're gonna reduce these parameters. So have 20 and 16, for instance. This is gonna be 8. Yes, so that it does some very quick baking and live resolution. Let's leave it in 10. Yeah, so that's mostly important because you know, this is better. Yeah, this is better. It got a lot. This yeah, this looks a lot better. We're gonna create a yeah, this is a vehicle light map. Yeah, this directional light. Probably could do a mixed, or we could have it in real time. I don't know. Real time is alright, I think. Yeah. And this plane, this is currently getting most of its stuff from if it's coming from the skybox, so that's cool. That's how it's gotta be. So yeah, scale and light map. We're gonna so let's see what is the yeah, it's taking the whole light map. We're gonna make it smaller. Let's see, 0.05. Let's see what happens. Yeah, if you see now, instead of having a 1024 times 1024, we have only a 512 times 512 light map, and we could even reduce this one, but that's alright. We will add more stuff later. Yep. So this is gonna be the ground, and I don't know, we could add a couple of objects to, so we have something to collide with later on. So I don't know, we could put this here. It's gonna be 0.5. No, maybe because we're gonna make it bigger. Let's put it at 2, and we're gonna make it at 0 and -10. We're gonna make it big. We're gonna make this 4, and this is gonna be 20, for instance. This is gonna be a wall. Yep. Which is good. Gonna have another one, for instance. We're gonna rotate it around. So -15. 0. Oh well, maybe it's a min. And this could be 25, for instance, and we could add a make this here. We're gonna add a new one too. We're gonna make it like this. I don't know, here. I'm gonna make it bigger. I'm gonna put them here. Just to avoid this annoying issue of having, since the round is 100, if you make them childs of round, the scale gets kind of weird. So I'm gonna create a new object, empty, which is gonna be the environment root, and it's gonna be in the center of coordinates, and then we put everything under that one, which makes it a lot easier to deal with. So I'll make 10, no, probably 8, and this is gonna be 8, for instance, and we're gonna make it about 105. And it's 105. Yeah, let's see. Let's make it like these. Something like this, right? So you could put it here. If this could be 0, this could be 0, 2. How about this? And we can something like this. So we got like this cube we are gonna use to 8 and 6, for instance. There, whatever. Just the thing is that we want these to be used to go up that wall there, so we can jump here and go there. It's just well, a few things that we have, and I'm gonna add a 3D object. There's gonna be a cylinder here, and we're gonna put a couple of columns. 0, 0, 0. This is gonna be 0.5, right? And then there. Now we're gonna make it bigger. Have, say this is 15, and then this is gonna be a 2 again. We're gonna make these. No, it's gonna be this 2, and we're gonna be let's make it a little bit bigger. Yeah, this looks good. I don't like the column. Let's make these 3. No, not 3, maybe 2.5. 2.75. Yep. So this way, as you can see, the whole column uses the cylinder part of the capsule. And this is going to be a column. So we're going to create a bunch of them. So how about 4? And that is going to be at 8. This is gonna be a 12, for instance. This is, I don't know. We could add a few more, like, it could be here. And this could be at 23. And we have another one at 27. We have these three duplicated and move all the way here. And then have these two duplicated and moved here. Yeah, and we could add a another cube like this one, duplicated, put it here. It's gonna be like maybe like 4, I don't know. This is gonna be like how much is this? 20. So we're trying to get these to be 6. This is gonna be 18, 16. 16 is okay. Y is gonna be 1, and this is gonna be 16. Alright, this is, this looks a little bit like a like the ceiling of a temple. I'm gonna put it at 4, 4 and 5. 7. Okay. Yeah, I don't know. I think that looks cool. It's nice, and we could use this later to for the camera, to make sure the camera, when you go inside, you look around, you look, and you don't collide with us with columns, etc. Everything inside the environment is going to be static, and we're going to also make sure that everything in here has got a scale alignment set 0.1, for instance. So when we generate the lighting, it's not very big. Yeah, still one texture, and yeah, look, it looks nice. Yeah. Yeah. I mean, we could use different materials, but for the time being, that's it. We have created a playground, a scene. That's cool. That's great. We will use it later. So now that we have all these, and actually I'm gonna be moving, because if our environment is there, I'm gonna be moving this a little bit, like here. So yeah, that's better. So yeah, we got our playground scene. Now it's time to start working on the character. So the first thing we're gonna do is we're gonna be adding the 3D model and animation. So models, we're gonna add models, and we're gonna get our Jamo character and the textures here. There we go. Jamo, this character here is quite nice, and the textures. I've got the albedo, ambient occlusion, metal smoothness, and normal. So let's create a prefab with the character. Yep. So to create a prefab, we're gonna move Jamo here. We're gonna put him here at 0, 0, 0. Okay, and we're gonna create a material. Actually, since we got everything here, let's create it here. We're gonna call these characters, etc. And we're gonna create a material, which is called Jamo. Gonna set the textures for the albedo, ambient occlusion, metallic smoothness, and normal mapping. This is fixed now. This texture is a normal map, yeah. We're gonna get this, and now we're gonna give it to Jammo. Everything in Jammo needs to be like this. So all of them. Jammo. Okay. Oops, not this. This would be different. We can have a different material. It's gonna be Jammo ice matte, and it's not gonna be lit, but it's gonna be, damn it, unlit. Yes, unlit. I'm gonna give him some nice yellow eyes, for instance. Yeah. For some reason, this one is not. It's not using Jammo matte. Why not? Oh no. But now it's okay, I think. Yeah. Good. So we have our Jammo character here. That's good. And if we do nothing, then we get these. Probably our camera should change and should be here. So we could bring it a little bit closer to the character. And turn it around and look at the character. Why not? Like this. So by default we got this character. It's there. Good, but we don't have animation, which is alright so far. What we're gonna be doing is we're gonna be changing this to Jammo, calling it Jammo, and we're gonna make a prefab with it. So we're gonna remove all the unpack prefab, and then we're gonna create a new one, because in this case this is completely new prefab, and I want to, to keep references to whatever this FEX prefab, auto-generated prefab file here has. I just get rid of it, which is good. And we're not gonna be changing this model anyway, so yeah, it's all right to do it here. So we've got the character, but it's not moving. It's got nothing because we are not moving it anyway. So the first thing we're gonna do is we're gonna implement a very simple movement controller, and we'll work from there. Okay, so we're gonna create a script, and we're gonna call it move controller. We're gonna open it. And here we go. So basically this script handles the movement of a character based on some given inputs. So as we did with the tanks, we're gonna do it from the start. We're gonna have some public variables here, like the speed, public float speed, so max speed. It's gonna be, I don't know, say 2.0. Float acceleration 1.0, 2.0, I don't know. We should see 1.5 for instance. We will change it later. And we're gonna have a vector 2 for the inputs, which are gonna be the inputs, the movement inputs from the player or the AI or whatever. And also we're gonna have a vector 2, which is gonna be the velocity, which is the one that we're gonna be updating. In the properties, we need to expose the input so that someone can change it from a different component, from a different class. And then we're gonna work, do most of our work in the update. So the first thing is, I like to do this always first, build dt equals time, build time. Then we are gonna be calculating the movement with the current inputs, the movement with the current inputs, and reset the inputs. We're gonna have to also apply the movement and so on, but anyway. This is good because, you know, without doing anything, next tick is gonna be 0, 0. So even if you had an AI, you could just rely on only giving it a movement inputs when you think it, when you want it to move. Otherwise, it's just 0, 0. So we're gonna calculate the movement with the current inputs. So the first thing we're gonna do is we're gonna calculate the ideal velocity. So the ideal velocity is going to be in 2D. So we're going to be using left and right to rotate the character, and forward and backwards to go at the maximum speed. So no, let's not do this. First, let's do the rotation. So we're gonna use for that the input x. The rotation, we're gonna use a constant angular speed. It's gonna be I don't know, 120 degrees per second. So basically we're gonna do the angle offset is gonna be the inputs dot x times the angular speed times the d. And this is in degrees. So we can apply, and then we can apply a rotation around the x, the y axis. We can do it in different ways, but I'm not sure. I mean, transform, rotate around. An axis, which is going to be 0.0, 1.0, 0.0, and the angle is going to be angle offset x. Yeah, rotate around is obsolete, that's right. So we now use rotate, which has this option, right? Or we can use directly. We could even give this 0.0, the offset here, 0.0, which is more convenient. That basically does a local space rotation around the y-axis. And just to make sure that this is working fine, the next thing we're going to do is we are going to create another class that is the player player controller. I think we're gonna be calling it. And this one is going to basically the players converts the players' inputs to inputs for the different controllers, movement, attack, etc. The character player controls. So we are gonna need to keep a reference to those controllers that we are gonna be modifying. In this case, we only have one, so it's the movement controller. We need to get it in the start. I think I've mentioned it before, but anyway, we're gonna use assert here to say move controller is not null. Basically, if there is no move controller, this is gonna assert and tell us that you need a move controller. It's gonna crash later on too, but this first one is gonna tell us, hey, the problem here is that you don't have a valid move controller. And here we're gonna build up move inputs. So float move x is gonna be input at axis roll horizontal. I'm not sure if it's called horizontal. I'm gonna check it now, but first let's do the same thing with vertical. And it's gonna be here, vector 2, move x, move y. In the project settings, we can go to the input manager, check the axis, and yeah, it looks like we have a horizontal with left and right arrows, and a vertical one with up and down. Looks good. We get the inputs and we apply them to the move controller. That's it. It's as simple as that. We are going to now add this player controller and move controller. And I'm going to do one more thing, and it's in the script execution order, I'm going to put the player controller, and I'm going to give it -10. That means that it's going to execute before other controllers, like the move controller. And that's important because that way, you get the inputs first, and then you apply the inputs. Otherwise, you would go one tick behind. Apply. Yeah. And it's not a big deal, but why would you do? Why would you want that? That looks good. It's rotating at a constant speed. Great. Now we want to make it move. Let's go. So, well, with these we have the input. Now we're gonna be calculating the target speed. So we're gonna be using a float for speed because I think the character is always gonna be moving in the way it's facing, and it's just it's this velocity what's gonna change. I mean, we could do it with a 2D. Well, let's do it with 2D. It's gonna be fun. Maybe later we can decide to change it if we want. So. first we calculate the speed. So we're gonna be using the forward vector, and we're gonna ensure that it's in the xc plane, which it should always be, but just in case, we're gonna make sure it's in the xc plane. And that should be probably ideal. We only care about the x and c, so on the other hand, we could use that one. Ideal speed is going to be a new vectors 2 forward.x times so the ideal speed is going to be inputs.y times max speed, and this is going to be the ideal velocity. Ideal speed. Now we have a 2D vector with the ideal velocity. We're going to accelerate towards the ideal velocity. So, basically, the velocity offset is going to be ideal velocity minus velocity, the current velocity, max vel offset is going to be acceleration times delta time. We're going to offset is going to be vector 2 clamp magnitude vel offset and the max length, and yes, update the velocity, and that should be it. So it's not working. Okay, pressing forward, backwards, it's not working. So puts the y, max speed. Let's see. Well, one of the things that you may not know is that you can see in YAML, we can change this to debug, and then we can see the current inputs. That's right. So it's not working because we're not applying the velocity. Damn it. Yeah. It's gonna be the velocity seems to be, we don't want to right now we don't want to move the character in the y direction, in the y axis, so yeah, it's gonna be like this, and hopefully I didn't make a mistake this time. So well, this character is very slow in every possible way. Let's see, how about this? How about 3 and 5? Yeah, I like this a lot better. Okay, the thing is, as you can see, the character is not adapting to anything. And the reason for that is that we don't have any kind of physics or anything here. If we make the character go a little bit higher, then yeah, the character is gonna stay high. There is nothing there. So what we're gonna be using here is a character controller, which is, I mean, it's debatable whether a character controller is the appropriate way of moving a character, and probably if you want a platformer, you may want to use something else, because the character controller may be a little bit too constraining. I don't know. For the purpose of this example, I think the character controller is the simplest way of getting a character to move in a nice way. So basically we have the character controller here, and yeah, this has got a so like this. So we don't want this to be so high, probably something more like 1.7, and that means 0.85. Yeah, that looks about right, doesn't it? Maybe a little bit smaller. How about 1.5? Oh gosh, 1.75. Now that's too small. 1.8 and 1.6, and I'm gonna be making it a little bit. Oops. This is like too big, so no, something like this. It's fine, like 0.4. Yeah, 0.4, 0.375. Yeah, seems like it should be okay. 0.3. 1.35 seems okay. Yeah, I think so. So now you can see that there is a capsule that is kind of around the player. That is the one that we're going to be using for collision detection. And we have other parameters here like the slope limit or the step offset, the maximum step offset, which define how the character can interact with surfaces like slopes and stairs. We're not going to be changing that. What we are going to be doing now, if we apply these, character is still, it's not moving, because these character controller things are gonna be ignored, because we are using we're in the move controller, we're setting the position all the time. So instead of doing that, what we're gonna be doing is we're gonna be using the character controller to move our character, which is the right way to go. The character controller is a component that we're gonna get in the start. And yeah, so we get in the start. I believe rotation, I'm not sure. And there is no rotate here. So we got two options. We can, in here, where we can basically set the velocity, or we could, alternatively, we could do which doesn't seem, it's not something that it likes apparently. No, it's only get variable. Okay, so we can only set the movement. So this is the movement offset, and we just apply it. No. stop falling. That's annoying. Oh, that's because we have to set the gravity ourselves. I forgot about that. Well, that's not a big deal. It's easy. So we can use custom gravity, or we can use the normal physics defined gravity, and if we wanted to change it, we could do something like float gravity factor here. This is going to be better for 1.0. Oh, by the way, let's leave these to the these. This is going to be 5.0, and this is 3, which is the values that we have there, so that if we create a new one, we don't have to set them again. And yeah, the offset. We calculate the gravity acceleration. It's going to be dt times physics, that's gravity factor times physics gravity. We could use vector 3 here, but in all honesty, this is going to be only the y-axis, because we are not going to be working with a gravity in a different axis. We're just using the y as the up. So this is going to be the gravity acceleration. So gravity, yeah, that's the acceleration. That means that we have to change the velocity, and in order to do that, we have to have a 3D velocity. So our velocity now. So again, instead of having an ideal velocity like that, we have a 3D velocity, which is basically ideal speed times forward. The offset is going to be a 3D, ideal the velocity. We use these, and the velocity, we increase the velocity, we apply the gravity. To be honest, we could use a vector 3 axle, because that is more consistent, and we can add the gravity acceleration to the velocity, and the move offset is going to be at dt times velocity. One of the things that we may want to do, if we are colliding with the ground, reset the y component of the velocity. I believe there is something like is grounded, that's right. So this way, if we touch the ground, we just reset the y part of the velocity, but we still keep the x and z part, so you know it makes sense. Yeah, let's see. Seems to be working. This is something that we could work on fixing, like when it's grounded, to make sure that it keeps its feet on the ground. One of the things that annoy me a lot is this offset here. As you can see, it's not on the ground, it's a little bit over the ground, right? And how much is that one? Well, actually 0.08, which is the skin width. I'm gonna do it to 5, and I'm gonna reduce the size of this to 1.5. And hopefully that means, yeah, that now the character is literally on the ground. its feet are on the ground. Yeah, and now, yeah, we can move it, and it moves pretty much the way you would expect. Okay, so this seems to be working. So we could stop here. We can start so that in the next video we can start working on the animations. So yeah, how about we do that? Let's do this. We're gonna wrap it up here. I hope you guys enjoyed it. This one was a very simple video. We just did some basic stuff on the character, but I think it's important to start from the beginning. I think this also may serve as a foundation for those of you that haven't seen the tanks tutorials, and I hope you liked it. If you liked it, please hit the like button, and I hope to see you guys in the next video. Bye.